In metal additive manufacturing, there are several technologies in play. Some, such as selective laser sintering, fuse powdered metal material in a bed to build parts. Others use ultrasonic welding of foil sheet material. Direct metal deposition, which is what Gefertec uses, works with wire stock to lay a bead of solid metal, essentially building the part with a welding process. We stopped by Gefertec to check out their new machine that builds parts with unique 5-axis motion and direct metal deposition.
So this is our Gefertec ARC405 series, so a small wire and arc printer. In general, it's basically a CNC system. So we have two kind of standard technologies we connect in this machine, and this is CNC-based 5-axis system. So you got a turning and tilting table, X, Y, Z axis, and and then the welding components, like all standard components. We put this together. So we use solid wire. It's basically welding wires, so it's a big variety of materials available in the market, and also a lot of knowledge, which makes it very easy to kind of include such a system in a normal working environment. We're really looking for big parts. It's kind of a high deposition rate process, so that means that we have, with the wire and the melting process, we create a lot of material, or we can deposit a lot of material. So that means we can print big parts very efficiently, and also price-wise it makes sense to print this compared to powder processes. For example, you would have big chamber you need to fill with powder, which is very expensive. In this case, printing a part from the wire is way cheaper and easier to do, so we look into real big parts, and that is basically our small machine. The big machine is probably double the size. Basically, if you look at the parts we do, you will see this staircase situation you have in additive manufacturing quite well here, because we have quite thick layers, and so layer height is something between 1.5 and 3.5 millimeters. Thickness 4 millimeters up to whatever you want. So it's probably way rougher than other processes you might know. That's why we need machining on majority of the phases afterwards. But we see it as it's a very fast process. It still makes sense to do this, to create this part in 2 steps, because you still save a lot of time, a lot of lead time in terms of reacting on design changes. A lot of time, if you look at such a part, machining it from a big blank material, so it will still be less waste and less material to machine than conventional manufacturing. We see a lot of applications for such technology. We say this is made for medium to low complexity parts. So we're probably not talking about the small, really complex structures which are done by powder bed, for example. Here we are really looking at bigger structures like those impellers, basically everything which involves a lot of machining, and maybe expensive materials. So we work in aerospace applications for titanium, there's stainless steel applications for those impellers. We are working in tooling, repairs of tools and dies and forms. So this is all possible, and that's why we also have these big machines. On a big 3-axis system you can place up to 3 tons of part weight. So you can repair even large forms and do an additive repair on them, and do multi-materials. As we use wire, it's easy to change material and the wire stock. So it's possible to have a lot of different applications. We just try to kind of change the manufacturing method, and that I think is makes it easier to get you feet into this AM door. Let's call it like this, because basically a lot of engineers, they are scared for, a lot of people. I think that's normal that you're scared for changing your working habits and things like that. And if you now have a small company, medium-sized company, they don't want to spend their time in developing new designs and new processes and everything like that. They want to earn money with the product. So, and that's basically our idea, to make it as simple as possible and still give all the advantages of this additive technology.